In this video, we're going to use properties, theorems, and definitions to form proofs about parallel lines and transversals. So first, let's review ourselves on our postulates and theorems for corresponding alternate interior, alternate exterior, same side interior and exterior angles that have to do with parallel lines and transversals. So notice that each one of those statements is written in that if-then format. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Notice we have to have parallel lines first before we can prove that corresponding angles are congruent. So we have to have that condition before we can prove angles congruent. We're going to use these in our theorems to prove certain angles are congruent, or angles might be supplementary, like in the case of same side interior or exterior. So here in this proof, I'm given that A is parallel to B. I can see that from the picture, and I have a few of the angles labeled as 1, 2, and 3. I'm going to prove that angle 1 is congruent to angle 2. Well, if A is parallel to B, we know by our corresponding angles postulate that 1 will be congruent to 3. So using that as a reason in our proof, we now know 1 is congruent to 3. We also know from our picture something about angles 3 and angle 2. Angle 3 and 2 are vertical angles, and we know vertical angles are congruent. So our next statement in our theorem could be that angle 2 is congruent to angle 3. Well, notice here we have angle 1 congruent to angle 3 and 2 congruent to angle 3. So now I can state that angle 1 is congruent to angle 2 by the transitive property. Notice from the picture that 1 and 2 are actually alternate exterior angles. And so with this proof, what we've done is we've proven the alternate exterior angle theorem. Our next example, we have angle 1 and angle 2 that we want to prove congruent. We're given that A and B are parallel lines. So we're starting with that fact that the lines are parallel. So we know angle 1 and angle 2 are corresponding angles. Well, we know on the corresponding angles postulate says that corresponding angles must be congruent. And so I've now proven that 1 is congruent to 2. Given that A is parallel to B, prove that the measure of angle 1 plus the measure of angle 2 is equal to 180. So let's develop our plan before we start our proof. Looking at the picture, we know angles 1 and 2 are same side interior angles. Well, based on our theorem, we know that that makes those angles supplementary. So the consecutive interior angles theorem says that 1 is supplementary to 2. Well, what does it mean to be supplementary? Being supplementary means those angle measures have to add to equal to 180 degrees. So being supplementary means that. So that's our reason in our proof, the definition of supplementary. Our next example, given that L is parallel to M, and angle 2 is congruent to angle 4. I want to prove that 3 is congruent to 4. So looking at the picture, we know we're dealing with angles 2, 3, and 4. We know that angles 2 and 3 are alternate interior angles. And we want to relate 3 to 4 instead of 2 to 4. So we're going to need to use those things in our proof to be able to finally state that 4 is congruent to 3. Well, first, from the picture, we knew that 2 and 3 are alternate interior angles. And the alternate interior angle theorem says if the lines are parallel, then those alternate interior angles are congruent. So 2 has to be congruent to 3. We know that 2 is congruent to 3 by the alternate interior angle theorem. Well, we were given that 2 is congruent to 4, and that 2 is congruent to 3 we now know because of the alternate interior angle theorem. Well, we can cut out that middleman, and by the transitive property and say that 3 is congruent to 4. Notice that this statement is almost what we needed for our final statement. We just need to switch it around. In order to switch something around, we have to use that symmetric property. So now we can state that angle 4 is congruent to angle 3 by the symmetric property. Once we've proven that statement, we know we're finished with our proof.